Welcome everyone to another Kuta worksheet tutorial. We're doing trigonometry to find lengths, and we're talking about right triangles when we're talking about trigonometry. Now, I'm going to briefly go over sine, cosine, and tangent. If you already know it, skip this section, just fast forward a little bit. If this is too fast for you, I would suggest going back and watching my other videos on trigonometric ratios. But otherwise, we're going to kind of jump right into it. The main thing we need to understand is that the cosine, the sine, and the tangent are all ratios of the different sides of a right triangle. So I'm listing them here. And then the last thing we need to know, well, not maybe kind of the first thing, is that when we have a triangle, we have our given angle, our reference angle, okay, we'll call that theta, and then the sides are labeled in reference to that angle. So we would have the opposite here, the adjacent next to that given angle, and the hypotenuse is always opposite that 90-degree angle. Okay, so this is kind of like the foundation of what we're going to use in order to solve for these lengths. So we're asked to find the missing side, round to the nearest tenth. And we have here, number one, we have a given angle. Okay, so we have this given angle, 27. We have some other measurements given, so we need to handle those. And then we're asked to find x, okay? So what's our first step? Step one, we always want to identify reference angle. Step one, reference angle. So we already have that step done. We already identified that in yellow. So we had this in yellow, our reference angle. So we're done with step one. Step two is label sides. So we want to label all the sides and figure out what sides we're working with here. So the hypotenuse is always opposite the 90-degree angle. Okay, so we have the hypotenuse there. This is the adjacent side. It's always touching the reference angle. And then x is going to be our opposite side. Okay, so that's all labeled there. So step three. This is probably the toughest part. We have to determine which trig ratio to use. Which trig ratio to use. Now, what do I mean by that? Well, see here that we have some of the sides given and some that we're looking for. What do we have given? Well, we have given is the adjacent side. We know the adjacent side, this one right here, is 10. So we have that as a given. The hypotenuse, we don't really care about. We don't have information on it, nor do we want to find information on it. So we're going to kind of ignore the hypotenuse for now. Okay? Just keep that in mind. And then lastly, we're looking for the opposite side. So the opposite side is important to us. Now, to determine, I forgot an E. I hope you guys didn't notice. To determine which trig ratio to use, we need to look over here and look which trig function has opposite and adjacent in the trig function. So we're going to look over here and we're going to say, okay, sine has opposite and hypotenuse. We don't want hypotenuse, so that one's out. Cosine, this one uses adjacent and hypotenuse. Again, hypotenuse, but that one's out because we don't have information, nor do we care. Last one, tangent, opposite and adjacent. We're looking for opposite side. We are given the adjacent side, so tangent is going to be our trig function that we use in this case. So we are going to use tangent. So the tangent of theta, again, is equal to the opposite over the adjacent. Step four, we are going to plug into trig ratio. What are we going to plug into it? We're going to plug in our known values. So we know tangent of not just any angle, we know it's of 27 degrees is equal to our opposite side we know is x, our adjacent side we know is 10. So we plugged in everything that we knew. Okay, we have tangent 27. Let me actually change the color on these. I think it will add a little bit of an effect, make you see it a little bit more clearly. Then we have x and 10, and we know that these are the given pieces of information originally, and we're basically ready to go. So now we take the last step in step 5, solve for variable. And I put solve for variable instead of x because sometimes it's y, b, a, whatever letter it is, okay? All right, now, here's my trick to it. So I have some hints and tips and tricks. Of course, that's why you're watching this video, hopefully. My tip is put this tangent over 1. Whatever this trig function is right here, always put it over 1. And the reason why is because I think it makes it easier when you have the left side as a fraction and the right side as a fraction, okay? So both sides are a fraction now, and this is going to make it easier. Why? Well, what we're going to do is we are going to cross multiply and solve for our tangent, okay? So I'm going to cross multiply here, so I have 10 times tangent of 27. I'm just going to keep it written as tangent of 27 until I'm basically done, okay? And then I have equals x. So x times 1, which is just x, sorry. Just want to clarify that. So then we have tangent of 27 times 10, and that's going to be equal to x. We're almost done. So all I'm going to do now on my calculator is type in 10 times, so I'm typing this into my calculator, okay, just so you know what I'm using a calculator. Sorry, normally I draw a pretty good calculator. That one's a little lacking, but I'm just going to type this thing, that expression, into my calculator. And each calculator is different. Some calculators you'll need to type 27 times, excuse me, you'll have to type in 27 tangent and then hit enter. My calculators, I type in tangent, then 27. So it just depends on your calculator. But anyway, I get 5.095. What are we rounding to? Whoops, I thought I was writing. 5.095. What are we rounding to? So the nearest tenth. Oh, great. Okay, so I only need the 100th place because I'm rounding to the nearest tenth. It's a 9, so I'm going to round up. 5.1 is equal to x. What does this mean? Let's think of the context of the problem. This is the missing side. Okay, and that makes sense. If this is 27 degrees, then that means this side right here is 63 degrees. So obviously this side needs to be bigger than this opposite side, okay? The bigger the angle, the bigger the side. So that's 27, so it's got to be smaller. The biggest side is obviously the hypotenuse. It has 90-degree angles. This one's 5.1, so we know we're good. It's smaller than our other side based on the angle measure, and that's our answer, okay? Let's go ahead and do another one. So we had, that one's the same thing. Okay, here's one with hypotenuse. We'll go over and jump to number 4. So let's go through the 5-step process again. Okay, reference angle number 1. Reference angle is 46. Done. Let's label the sides. Opposite, adjacent, hypotenuse. Now what I would do is if you don't have anything on the adjacent side, I would just erase it. Okay, this will make it easier for you to do step 3, which is determine your trig ratio. Which of these uses opposite and hypotenuse? Well, SOHCAHTOA is a way to remember the trigonometric functions. We have O, opposite, and H, hypotenuse, so it's sine. So we're looking for sine of theta is equal to opposite over hypotenuse. My sine of 46 is what we're plugging in here. Okay, sine of 46, and that is equal to my opposite side, 8 over x. Okay, 8 over x. Now, what do I do from here? I solve. So this is why I like to put it over 1. When I put it over 1, I have an x in the denominator, and usually that's pretty tough to do if you're not doing cross multiplication. But this time when I do cross multiplication, it makes it way easier. So I have x times sine 46 equals 8 times 1, which is just 8. So you see, now I divide by sine 46. It makes it obvious that I need to divide sine 46. So again, my recommendation is put both sides as fractions. Okay, so put the whatever trig function it is over 1. This cancels out on the left side. You're left with just x, and then we just do in my calculator 8 divided by, and I type sine of 46. Make sure you are in degree mode for this, by the way. And I get 11.12. So rounded is just going to be 11.1. Now let's check to see how that compares. Okay, it's bigger than my opposite side. That's good because that's my hypotenuse. My hypotenuse needs to be bigger than my opposite side, so I'm good. That's how I do that one. Let's see if there's another trig. We've used tangent. We've used sine. Let's see if we can get a cosine up in here. Okay, so here's a cosine. Oh, I gave it away, sorry. Well, here's our reference angle first, and then we have our adjacent side, and then we have our hypotenuse. We don't have the sine. I'm not even going to label it, or opposite side. So let's go ahead and identify our trig function. We have adjacent hypotenuse, adjacent hypotenuse, adjacent hypotenuse. We're looking at cosine for this guy. So cosine of 54, I'm going to go a little bit quicker this time, 54 is going to be equal to x over 12, adjacent over hypotenuse. I'm going to put this over 1, and I'm ready to cross multiply. So I'm going to cross multiply here. I get 12 times cosine 54 equals x times 1, which is x. So this one's easy. I don't have to divide anything. X is already by itself. And now I just do 12 times cosine of 54 degrees. And I get 7.1 rounded. 7.1. It was 7.05. That's 7.1 rounded. That's smaller than my hypotenuse. That makes me feel good and warm inside. So I'm done with that one. All these problems are basically the same. So if you want me to do another one, I'll do one at random. Usually the last one, I don't know, is the toughest. I don't know if that's the case here. But we have our reference angle. Okay. See if you can try it on your own. Pause this video. See if you can try it on your own and then check your answer. Okay. You pause it. You're not doing this, are you? You're just going to wait for me to do it? All right, fair enough. So here's my reference angle. That makes this the opposite side. This the hypotenuse. I'm going to be using sine. Sine uses opposite over hypotenuse. So that's sine of 37 is equal to 37 over x. I put it over 1. It makes it easier to solve this with cross multiplication. So now I cross multiply 37 times 1, sine of 37 times x. X times sine 37, I like to put the x first, so it doesn't look like it's 370x or whatever, 37x equals 37. I divide both sides by sine 37, and this is where my calculator comes in handy. I'm going to draw a calculator because just in case you aren't sure what it looks like that. Type it into your calculator, however your calculator works, and we get x equals 37 divided by sine 37. And I get, that sounds right, I get 61.5 rounded. 48, which is 5. This needs to be bigger than my opposite side. The hypotenuse needs to be biggest. That's a good way to check. And that's all there is, folks. Hope you guys enjoyed this video. If you need me to do any problems on this second page, let me know. Leave a comment. And hope to see you next time on West Explains Best. Thanks for watching. You guys can go now.